Hello, this short video has been produced to help with questions that may appear in the Scottish Qualification Authority's exam for the Higher Physics course. In this clip, we're looking at the particles and waves section of the course and on nuclear reactions. So here we have a question. Beta emission is a form of decay of an unstable nucleus. If the following goes through a beta decay process, what is the resulting nucleus that is formed? And there we have a carbon atom, and we know that there's 6 protons there and then 14 neutrons and protons added together. And we have a selection of answers. So what do we have to do? Well, we should read the question closely to pick out things we're being asked about. Clearly, this is a beta decay process question. That's what our brains should be looking for. Look to see if there's any options that we can easily ignore. Nothing obvious here. Recall which part of the course we're operating in so we can ignore everything else, and read the question again, saying all the words out loud in your brain to yourself. Avoid overcomplicating. If you find yourself getting lost in processes, just stop and start again. Things are never as difficult as your brain thinks they might be. So this is a question where we have to remember from the course which process beta decay is. We have an alpha decay and beta decay, and we need to know the difference. And there is a hint provided in the choice of answers given. We can see that from the selection, the movement in the mass number and atomic number is nothing more than a proton or a neutron. So it's unlikely this is going to be alpha decay, because if we remember, alpha decay is about losing a particle that is a helium nucleus. And as long as you remember that, then clearly the other process must be beta decay. But this is where you have to recall beta decay from the course. We have the beta decay process shown here, and as you can see, it's about the evolution of a neutron to a proton, an electron, and an electron neutrino. So what we have to do is match the process to our carbon atom to see what happens, and that will let us understand the solution. So we can see that there is a proton that's being gotten rid of. It's creating, a neutron, and it is creating a proton. So if we're creating a proton, this number is the proton number, and this number is the conjoined protons plus neutrons. So we would expect this number to go up by 1 proton, and that really does hint at what the answer should be. If it's gaining a proton, remember that this number is the one that guides the choice of which element we're looking at. So if that number changes, then the element must change as well. That really does narrow down our choices. So if we come to the answer, we know that we're looking at beta decay, the evolution from a neutron to a proton. And we can see what happens. The proton number must go up, and there it is. It goes from 6 to 7. And if the proton number rises, then the element type must also change. So we've gone from a carbon atom to a nitrogen atom. And that is enough to let us choose the answer. We don't need to do anything more in this question than understand that. So things to note about this question. Well, the trick is obviously to get the right process, know your alphas from your beta. And if we can just remember alpha is helium, then we'll know what the beta process is. You have to be careful that if you change the atomic number, you're changing the element type. So carbon has 6 protons, nitrogen 7, and that's a big giveaway. You have to be careful that you add a proton and not subtract one. It can be easy to think of it that way in your head because the phrase beta decay makes your brain think about loss. And actually, obviously, we are losing a neutron, but we're gaining a proton. Also, it's worth looking through the rest of the paper, as there may be another question on the same topic or a question that involves alpha or beta decay, and that question may show you the process written out. So it's worth having a quick flick forward or back to see if you can get some hints from other questions. So there we are. Here are some other examples. Do those at your pleasure and then get the answers from highpage/physicsfysx. Great, thanks very much for watching and see you in the next question.